All right, so today we are going to do two-dimensional figures. This will take 2 days. That's why I put 1-6A. So on Wednesday, we're not going to do 2 dimensions. What do you think we're going to do on Wednesday? 3-dimensional figures, all right? The 3-dimensional figures, we are going to take a day on it. It's really kind of easy. You don't really have to do anything. You just have to look at a picture and tell me what it is. That's basically what it is. This stuff right here is really big-time foundational stuff. This is stuff that you're going to see and you're going to need to know chapter after chapter after chapter in this book. So a lot of the stuff that we're doing here, you're going to see again, almost everything. Because every time I teach something, I'm thinking, oh, I know where they're going to do this later on. Yep, I know where they're going to do this later on. So I want to make sure that you understand how important it is to do this. All right, the first one's kind of easy. You already know this type of figure. All right, and it's called a circle. All right, everybody knows what a circle is, but there's a lot of stuff about circles you probably don't know. And we're going to learn how to describe a circle, what a circle is, how to name it, all that good stuff. Let me put a point right there. Okay? All right, so a circle, I'm not even going to give you the definition. You won't remember it. I'm not going to ask you on a quiz or test for the definition. But it's basically this. If I start from a certain point, that certain point is very important. It's not just some random point. I didn't just put a point here, put a point here, put a point here. All right? That point it's at a specific place. So if I drew a line segment from that point anywhere on the circle, and when I say on the circle, I'm not talking about inside the circle. I'm not talking about outside the circle. It's that white curved line that goes around. See that white line, that thing right there? That's the circle, all right? So this is not on the circle. Everybody see that? Where would that point be? Give me a good geometry word that you had on the quiz. It's the interior. It's inside the circle, right? It's inside that closed circle. So that'd be in the interior. What if I put a point out there? Where would that be? That's the exterior. What if I put a point right there? The point itself. Forget the line. Look, here, let's put a point right here. Where is that point? Exterior? It's on the outside of it? It's in it? It's inside it? It's on it. It's not a line. What is it? Thank you. Okay, I thought everybody would get that. It's on the circle. This is inside the circle, or interior. This is outside the circle, exterior. This one is where? On the circle. It's actually on it. Is this on it? No. A lot of people think of a circle. I used to have like a cardboard cutout of a circle. Here, I'll dump these out. See this little thing right here? That looks like a circle, doesn't it? A lot of people think like the whole thing is a circle, even the stuff inside of that. That's not the circle. What's the circle? Just the outer edge to it, okay? That's the circle. You got it? A point out here is outside the circle or the exterior. A point in here would be what? Interior of the circle. Everybody got it? Because a lot of people think that inside it is the circle. It's not. That point is on the circle. So here we go. If I take a line segment and connect that one special point that I put inside the circle to any point on the circle, watch. I could connect from here to here. I could connect from here to here. What do you think is true about all 3 of those line segments? They're all the same, exactly the same. So that point right there is really important. What if I put a point here and I connected to any point on the circle? See how short that one is? And what if I did it here? Would those two be equal to each other? No, they wouldn't, okay? Because this is just some random point. This is not a random point. Where do you think it is? Where do you think it's located? Okay, that's a good guess, in the middle or the midpoint. But on a circle, we call it the center of the circle. All right, the center of the circle. That's really, really important. And this point right here is just some point on the circle. There's nothing really special about that point. It's just on the circle. Again, it doesn't extend to outside. It doesn't come short of the circle. It hits right on the circle. All right, so that's the center of the circle. We describe the center of the circle with a capital letter. All right, doesn't matter what capital letter you use, I'll just use A. All right, so that is point A. So point A is the center of the circle. So I could ask you something on a quiz, and I could give you a picture with this, and I'll say, what is the center of the circle? Or name the center of the circle. Let's say it that. Yeah, you would just say point A, but do you need to write the word point? If it's a point, you just put a capital letter. You don't need to put a dot in front of it. I saw people doing that on the quiz. I didn't mark that wrong. I almost did. I thought about it because I told you guys not to put a dot in front of it. If it's a point, just use a capital letter. All right? So if I asked you the question, find or name the center of the circle, what would you say? Just A. That's it. Easy. All right? Oh, and you mentioned this earlier. I kind of blew by it because I wanted to get to it now. Yeah. Do you see this line segment right here? I'll make it a different color so it stands out a little bit. See that line segment right there? And this one and this one. They're all the same length, right? If you have a line segment that connects the center of the circle to a point on the circle. I'll try this again so that everybody's listening. If you connect the center of the circle to any point on the circle, you've made a little line segment there. I'll put a point B where that point is right there. That line segment, Owen said it earlier, that line segment is called the radius of the circle. I'm sure you've heard that word before. All right, that's the radius of the circle. It connects the center to any point on the circle. So what's this one? What's that one going to be right there? That's also going to be the radius of the circle, isn't it? All right, what's this one right here? It's also the radius of the circle. Now you're getting it, okay? So all three of these are the radius of the circle. Now, if I have three of them, I don't know if I've said this before. Let me do this. Change colors. If I have three of them or two or more, the plural, anybody know what the plural of radius is? Is it radiuses? It's not. I'll tell you that much. It's not radiuses. It is radii. R-A-D-I-I. It's kind of weird because we don't normally see two I's next to each other in the English language, but that would be the plural. I'll put PL for plural. So if you have more than one radius, we have two what? We have three what? Radii. Radii is how we say it. Okay? So that's kind of nice to know. All right? Can you have more than one center to that circle? No, there's only one center. You can have a bunch of radii, right? But what's true about the radii? They're all the same length. Good. Let's talk about how to name a radius. A radius is a what? Is it an angle? Is it a line? Is it a ray? Is it a line segment? Is it an angle? Or it's a line segment. So what if I asked you to name the radius of that circle? Then what would the name of that radius be? Yeah, not just AB, but what? No, not radius AB. What is it? What did we say it was? It's not a line. It's not a ray. What is it? It's a line segment. It's a line segment. So how do we write line segment? We put that little thing over top of it. So if I asked you to name the radius, it would be line segment AB. Don't just put AB. Don't put a line. This is not a line. It doesn't keep on going forever and ever. It starts here, stops here, or one or the other. Now, if you really wanted to, what else do you think you could call that radius? Well, let's not say BA. Let's put the word in front of it. What is it? No. Line segment, right. You could call it line segment BA, but I would not. Why not? Why do you think this is a little bit better? Because A is the what? Yeah, but it's the what? It's the center of the circle, right? It's the center of the circle. This would be okay. If I asked you, name the radius of the circle, and if you told me it was line segment BA, I would give it to you, all right? But it's not the best way to name it, all right? The best way to name it is line segment AB. Why? Because the center is at A. I don't think there's any rule that says you have to have the center first, all right? It's weird? What's weird about it? Yeah, it is a little weird because, why would you start there? The center is like the important part of it. Yeah. So I agree with you. I would think it's a little weird to call it line segment BA. It would be all right. I'd give it to you. But if we're going to name the radius, I would start at the center. Everybody good? All right. Let's do another thing. What if I did this? Let's do a different color. Come on. Okay. What if I said the length of AB was 5 inches? All right. So from A to B, and I measured, took a ruler, and I said, oh, it's 5 inches. Here's a question I could ask. I could say, find AB, and that's it. I just say, find AB. What does that mean when I don't have a line segment over top of it? What does it mean when I just say, find AB? Find the length of it. That's right. Find the measure or the length of line segment AB. So take a look at it. It's not hard to figure out. I put it right in there. It's just 5 inches. So I would say this. I would go AB equals what? 5 inches. And circle that whole thing. Don't just write 5 and circle it. Don't just write 5 inches and circle it. What do you write? AB equals 5 inches. We okay? All right. Let me think of... Oh, one more thing. What was the name of this circle? Or I should say that. I didn't even tell you that. What's the center of the circle? It's A. So what if I wanted to name the circle? So name the circle. It would be circle A. Right. We use the center. The center is really, really important on a circle. Okay, so we use the letter A. And here's a symbol. You know how we had symbols for lines, for line segment, for what else? Ray, for angle, all that kind of stuff. We have a symbol for a circle. And guess what it looks like? Yeah, very good. Okay, it's a circle, but then they put a little dot in the middle of it. All right, that kind of represents the center of the circle. So this represents circle. So I name a circle just by the center of the circle. So I would call this circle what? Circle A, and that's it. It's very simple. So if I asked you to name the circle and I gave you the picture, it would be circle A. So that little symbol right there, what does it mean? It means circle. If I said name the circle, yeah, that's what you would circle, like that. Okay? Excuse me. All right, that's enough about circles. It's not going to be the only time we talk about circles. In fact, we have a whole entire chapter. It's later on. It's towards the end of the year. A whole entire chapter just on circles. Can you imagine a whole chapter just on circles? I mean, what else is there to know? I mean, I think we pretty much covered it. No, there's a lot of stuff about circles that we can talk about. But right now, we're not going to get into that. We're just doing basic stuff right now. We're just learning vocab, right? Knowing how to label stuff, what the words mean, and that kind of thing. That's all we're doing right now. All right, let's do another word. This is another word you're going to see a lot. You'll probably see this more than you'll see circles, tell you the truth. All right, and here it is. Everybody, my little speech didn't do much, did it? Let all the heads down. Boom, 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 boom. 4 heads down. Goodness gracious. All right. It's called a polygon. All right, and it's made up of 2 words, basically. The prefix poly. Anybody know what that prefix poly means? It means many. All right, it means many. And the gon is short for angle. All right, so what's polygon? It's got many angles. All right, but it gets a little more specific than that. Listen to me. I'm not going to write down the definition. I'm not going to make you memorize it or anything like that, but I'm just going to describe it for you. It's a simple, closed, they say curve. A lot of times when we think of curve, we think rounded, all right? But it's an object, we'll say, okay? It's a simple, closed object that consists of only... So it's a simple closed curve. Again, the word curve doesn't always mean it's rounded, okay? That consists only of segments. So right there it says there's no rounding because the segment's always got to be a straight line, all right? So let's talk about this. It's a closed figure, all right? What does that mean it's closed? Well, I'm glad you asked. I'll show you. Like right there. Is that a closed figure? No, it's open right here, okay? See all those segments? They come to a point here, come to a point here, but these two don't come to a point, do they? Well, let's make it come to a point. Let's make it go like this. All right? So this thing would be considered a what? A polygon, all right? Because it's made up of segments, right? This is segment, 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 and it's closed, which means all these segments would attach, okay, or connect at their endpoints or intersect at the endpoints of the segments. Okay, so like this. Is that considered a polygon? No, it's not, okay, because the segments have to connect at the endpoints of each segment, all right? So that's not a polygon, but that is, all right? Let's talk about the point where they intersect. We have a name for that, all right? So that point right there where they intersect, it forms an angle, doesn't it? You see that? So when we had an angle, we've used this word before. This is not the first time you've heard this word. So when you had an angle and they connect at that common endpoint, what did we call that? Starts with a V. Vertex, that's right. So this is also a vertex. Right? It's the vertex of this angle, but it's also a vertex of the what? Polygon. They all are. It's a good question because I was about to show you. So that's a vertex, and that's a vertex. Since we have multiple vertexes, that's not the plural. I'll give you another plural. That would be a good one. That sounds kind of cool, but it's vertices. I should start calling them verti. I like that. But vertices is the plural. Okay, that's what you're going to hear. All right, so one vertex, two what? Vertices. Okay, so that's the plural of vertex. All right, everybody good? All right, what about, let's go different color. What about the actual segments themselves? They have a name. Whoops, it's supposed to be an arrow. See those line segments themselves? They're just called the sides of the polygon. All right, we're going to talk about that in quite a lot of detail in a minute. Everybody okay with that? Now, how many sides do I have with this polygon? 1, 2, 3, 4. So does every polygon just have 4 sides? No, it could be a bunch of different sides. What's the least number of sides that I could have in order to make it a polygon? 3. Very good. Okay, it would be 3. Somebody in the other class said 2, but watch. Could I have a closed figure with just 2 sides? So watch. What do I had that? Is there any way? No, there's not. All right, because look, if it's closed, then it would just be that same exact line segment, wouldn't it? All right, and that wouldn't be a closed figure. All right, like that, it's open, right? You got all this open area, so you can't have a 2, but you could have a what? A 3. All right, so that's the smallest one you can have. What's the largest polygon you can have? 20. So I can't have a polygon with 21 sides? There's no limit. So what is that? What number is that? An infinite, right? An infinite number of sides. But we're not going to have anything that's got an infinite number of sides. I will show you something that's kind of cool, though. I didn't do this in the other class while I'm thinking about it. So let's do it. Look, this thing, I can pick how many sides I wanted. Let's go kind of big. Let's go like 10. All right, see what that looks like. That's a 10-sided polygon. All right, let's double that. Let's go 20. Well, it is. We're going to talk about that in a second. Now look at that. That's got 20 sides. What's it starting to look like, though? Starting to look like a circle, isn't it? All right, and watch this. Let's go 100. 100 sides. See what that looks like. Now it really looks like a circle, doesn't it? All right. Now, it's not a circle, right, because it's made up of a bunch of straight segments, and you probably won't even be able to tell. I could probably zoom up to this. Actually, let's do this. Let's put a point here. I'm going to zoom in as much as I can. Look at that. It doesn't look like it's made of segments, does it? Okay, that's as much as I can zoom up. I can't zoom up any more than that. Let's see, where is the circle thing? Is it this way? There it goes. So look, Yeah, you can kind of tell a little bit. See, there's a little bit here and here, right? But the more and more you get, the closer and closer it looks like a circle, doesn't it? All right. There's other things that we're going to talk about. Maybe not in here, but that looked like a dot, didn't it? But it's really not a very circular dot. All right. Yeah, Deshaun? Question? Just raising your hand? You trying to? Don't try in here. You have to clean it up. Somebody explain it to him. I thought it was a good joke. See, look, if I clicked on it, watch this. How are you missing out on all this stuff?
I got everything going down. I'm not missing it.
See all those dots right there? That's the connection of the straight lines, the straight segments. Okay. So yeah, so that's only 100. What if I put 1,000 or 1,000,000?
Yeah, that's a circle, bro.
Yeah, it's pretty close to a circle. Okay. All right. Let me see the thing. Where did I put my pen? Is it in here? There it is. Here. All right, enough of that. Let's talk about polygons again. But we need to get somewhere with this. So, all right, let's do this. Let's not do 100. Let's do something reasonable. Let's go 8. It does not. Good question. All right. Now, the way the program did it, and if I hit the shift key, I know you don't see me hitting the shift key, but if I hit the shift key and grab a corner, when you say even, what do you mean? Oh, like 8 sides? No, you could have 7 sides, you could have 9 sides, it doesn't make any difference, okay? This one I just made 8. Polygon. No, it could be anything. Right. Yeah, I just use this because my program allows me to make it. It is an octagon. And we're going to talk about that. You're getting ahead of me. But that's okay. Watch. You could have something that looks like this. Like this. Like this. Yeah. That's some kind of crazy one, right? 1, 2, 3, 4, 5, 6. There's 6 sides right there, right? Are all the angles the same? Or all the sides the same? No, it's just some kind of random polygon. But it's still a polygon, right? And it's still a 6-sided polygon. But what we're going to do right now is we're going to talk about this. Look at all the sides. Now, the program did this. My computer program made all the sides exactly the same. So how would I know they're all exactly the same if I saw it in a book? The tick mark, very good. The other class could not think of that word tick, but you guys got it right away. Tick mark. Now, if I showed you this, let me scooch it over so I can write some stuff. If I showed you this, all the sides are equal. Anytime you have a polygon, when all the sides are equal to each other, we give it a special name. So I'm going to, I'll put this. All sides equal. We call it a EQUI, equilateral polygon. Okay? So when all the sides are equal, we call it equilateral. Lateral means sides. All right? Lateral means sides. You ever do a drill in basketball or football or something like that where they took the ball and they blew the whistle and they went to the left, they went to the right? That's called a lateral drill. All right? And so lateral means you go side to side. So lateral means sides. So equa, that's an easy one. What do you think that means? Equal, equal sides. That's right. So when all the sides are equal, it's equilateral. All right? What if, I'll tell you what, I'll just do this a different color instead of erasing all these other ones. What if you only knew, forget the red right now, okay? I'm not going to erase them, but forget the red. Just look at the yellow. What if you knew that every angle was equal to each other? Okay, so all the what? All the angles are equal. We have a name for that. So how do you think it's going to start? Equa. And we're talking about the angles this time. So they use the word angular. So we call that an equiangular polygon. All right, so if you only knew that all the angles, all the yellow stuff was equal to each other, then that's an equiangular polygon. And these are words that they're going to refer to, and you got to know what they mean. So that's why we're talking about it. Now, what if we combined it? We'll go green. Doesn't red and yellow make green when you mix them together? Anybody know their colors? I think it does.
Red and yellow?
Yeah, red and yellow. Doesn't that make green? Yeah, so I'll do it in green. So what if you knew that both the sides and the angles are equal, okay? So all the sides are equal to each other and all the angles are equal to each other. That's what I mean by both, all right? We have a name for that, and we call that a regular polygon. That's important. I know exactly where we're going to be studying this. Okay, it's later on. It's not in this chapter, but we will study this, so you need to know this a little bit later because we're going to talk about a regular polygon, all right? And it's very important. We're going to be doing some math, a lot of math. In fact, I'll give you a heads up. We are actually going to be able to figure out, without any other information, the only information I know is this is a regular polygon with 8 sides. And we're going to be able to figure out what each of these angles are equal to. Just by that information, nothing else. Isn't that crazy? We're not going to do it today, though. It'll be another chapter. It might be the next chapter. I can't remember. All right, we call that a regular polygon. So know those words. That's very, very important. All right, I got one more thing to go over. So now what we're going to do is we're going to classify a lot of the lower number side polygons have special names for them. All right, so let's talk about it. So if I have this many sides, I'm going to list a bunch of sides, and we are going to say the special name of the polygon. All right, this is important too because they're going to say, you know, what's the degree angle of a regular hexagon? You're like, what's a hexagon? I don't know what that is. Well, that's what we're going to talk about right now. So no, it's not 5. We'll talk about it. What about the number of sides? What's the smallest number of sides I can have? 3. So let's start with 3. Everybody knows what a 3-sided polygon is. What do we call that? It's a triangle. And again, I keep referring to what we're going to do later, just because my mind goes there. We have a whole entire chapter just about triangles. In fact, we have a whole entire chapter mainly, kind of close, just on right triangles. All right? And you kind of know what a right triangle is, don't you? We'll learn that later. All right, let's do this. What about 4 sides? What do you think we call a 4-sided polygon? You would think, right? And it's true that a square is a polygon and it's 4 sides. A rectangle is a polygon with 4 sides. But what if I drew something like this? Just some kind of funky looking thing. Is that a rectangle? It's got 4 sides. I thought you told me the name of a 4-sided figure is a rectangle. Is that a square?
No.
I thought you told me a 4-sided polygon is a square. So we got to have a more general name, don't we? Square and a rectangle are very specific. And we are going to talk about squares and rectangles, guess when? In another chapter, all right? I promise. We'll talk a lot about it. But right now, we call this, let's go back to this. We call this a quadrilateral. Quad meaning what? 4. All right. The word quad, you probably know that already. All right. It's 4. And then lateral. You got that word lateral in there. It means 4 sides. So that's any general 4-sided figure. So is a rectangle a quadrilateral? Yeah. Is a square a quadrilateral? Yeah. They're just special types of quadrilaterals. All right. But anything with 4 sides that's a closed figure is a quadrilateral. All right. Let's keep moving. We're running out of time. 5 is a pentagon. Pentagon is in Washington, D.C. There's a huge building, gigantic building in Washington, D.C. It's called the Pentagon. All right, it's where the military and stuff is all based. They were actually hit on 9/11, right? You guys know about 9/11, right? All right, and they hit New York, knocked down 2 buildings, horrible. But they also, plane crashed into the Pentagon as well and killed a bunch of people as well. Not near as many people as the towers, but it still killed a lot of people. All right, so Pentagon is something, and it looks just like what you think a pentagon would look like. It's got 5 sides, and it's a regular pentagon. It's a regular polygon. the one in Washington, D.C. All right, number 6, or 6 sides, is a hexagon. Somebody said hexagon earlier. It's 6 sides. Number 7's kind of weird. You don't hear this very often, but this book calls it a heptagon. Some books call it a septagon, S-E-P. I'm not going to write that down because this book uses hepta. And I had a book that I used to teach out of. They called it a 7gon. I guess they didn't want to use the prefix hepta. I don't know why. It is easier. Yep. But anyway, we're going to use hepta because that's the way this book does. 8, I already heard it. It's an octagon. What do you see probably every single day if you ever go outside? That's an octagon. A stop sign is a regular octagon. That means all the sides are equal, all the angles are equal to each other. All right? If you don't believe me, go out, take your ruler, take your protractor, and see. You'll find out a stop sign is that. I had a summer job for a bunch of years, like 5 years. And I worked for DelDOT, Department of Transportation, and we fixed signs. If signs got knocked down, we go out and put them back up. So I dealt with stop signs every single day. So there's something I bet you didn't know about me. Right? Nonagon. That's 9. 10 is a decagon. What's another prefix, or what's another word that we use deca for? It's N-O-N-A-G-O-N. Non-a-gon. Decagon. What's another word we use deca for? Decade for 10 what? Here's a word you probably never heard of. I don't think I ever heard of this until I started teaching out of this book. Okay, it's called a hendecagon. It is kind of weird. All right, but that's 11 sides. One more. This is the last one we're going to do. And you do hear of this one from time to time. It's a dodecagon. All right, and they stop right there at 12. They don't give you any more. All right, they figure they're the ones that are most common. You see those more than anything else. All right, we stopped a little short of where I wanted to stop. So remind me tomorrow we are going to name a polygon. All right. You do have some work, though. I think you should be able to do most of this. You're doing numbers 13 to 20. It's on the lesson plan thing I gave you earlier. So you're doing, that's section 16A. Section 16A.
Here's my homework, my lesson homework that I had to finish over the weekend.
1-2?
Yeah.
That was due a while back.
I know, but remember I came here with Miss Weber.
She took you out of here?
Yeah, we had to.
All right.
Sure.